Hey, 8th grade mathletes. This is Mr. Frechette. We're going to do a little bit of review of slope today. Calculating slope from a graph and calculating slope from 2 points. So, let me just go in present mode here. This is finding slope from graphs. And also, I'm going to add from points because we saw that today. So I'm going to move on to the next slide. And we're going to do a little bit of review with slope dude, right? So slope dude's diagram. You have to remember a couple things. Slope dude is he's not really a happy camper, I guess I should say. But when he's going up the hill, when we're reading this from left to right, he's going puff, puff positive because he's got to climb that hill. Oh, man. When he gets up to the top of the hill and he's ready to do a gnarly move, he goes down and he goes nice, 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 negative. He gets to the bottom of the hill and he's on zero slope or level ground, and it's not so fun. We call that zero fun. However, slope dude's fun really does end when he gets to the end of his route and he goes down a cliff and it's undefined, right? So undefined is a vertical line straight up and down on the y-axis, and what you'll end up finding is this is what the slope looks like. It could be any number, but it could, let's say it's 3 over 0. 3 over 0 can't happen. If you put it in your calculator, you can try to prove me wrong, but if you put it in your calculator, you're going to get an error. And an error is pretty normal. And if you get an error, that's what makes it undefined. It's a slope. You don't have a slope. It's undefined. It can't be calculated. So that's one thing we see there. So a little bit of review here. When we're thinking of slope, you got to think of m. M always equals rise over run. And I'll tell you in a minute what I mean when I say rise over run. So we have rise over run. I'm going to say m equals, the triangle here means change in y over change in x, right? So that's what we're comparing. We're comparing the change in y over the change in x. And then some of you, I believe everybody saw this today, we have y2 minus y1, and this is the slope formula, all divided by x2 minus x1. So this is the formula that we're going to be working more with as we go along with this, and I'm going to show you one of those examples on the next slide. Okay, so I'm going to erase this, and we're going to move on to the practice. We'll move on to the practice. And we're only going to do 2 of these today, so we're going to look at the top 2. The bottom 2, if you guys want to give them a try, you can. I'm going to give you some points when we get down there that you can use as practice. And then, that's something we can discuss in an email or something if you have any other questions. So if we look at this first one, we're just looking at a graph. We want to always consider, right, rise over run. Rise over run is always there, right? And that's the same thing as I talked about before. M is the same thing as change in y over change in x. Now, I'm going to label my horizontal axis, which is my x, and then my vertical axis, which is my y. So, what I need to understand is when I'm looking at a graph and I have 2 points, I can look at the graph, and in this case, when I'm moving left from right, this is nice, nice, negative. So this is actually a negative slope. I'm going to put that up there. It's good to identify because you've been identifying them all along, so we know that our slope's going to be negative. So in this, I'm just going to count down. I'm going to go from point to point. I'm going down 1, 2, 3, 4, 5, 6, 7, and I'm going to the right 1, 2, 3, 4, 5, 6, 8, 9. As you notice, that creates like a right triangle, right? You see this triangle right here on the board? That creates a triangle, so I'm going down 7, to the right 9, and over here I would write my slope is m equals negative 7 over 9. Now you should be saying to yourself, can I reduce that any farther? Can I make that a smaller fraction? And you'll find that you cannot. Negative 7/9 is already reduced. So that's what your slope is. You would rise or go down 7, and you would run 9. In this case, be to the right. So let's take a look at number 2. This time we're going to look at the points themselves. And I'll do this in purple. So we're going to look at our first point. This is 1, 2, 3. This is negative 3, negative 1. If we look at this point over here, it's 1, 2, 3. This is 3, 3, right? because we have 1, 2, 3, 1, 2, 3. So that's 3, 3. So we're still going to do the same thing, except we're going to be using our slope formula this time. So I'll write the slope formula up here. We have y2 minus y1 all over x2 minus x1. And we're going to go through and do that. And it's going to be very important to have your calculator with this, because now we're going back to adding and subtracting integers. So everything that we did at the beginning of the year is starting to make its way back to the stuff that we're doing right now. So if we label, and I'm going to go over here so I can label this for you so you guys can see. We'll do it in orange. This is your x1 right here. This is your x2, right? This is your y1, and this is your y2. Okay? So you need to remember that. You have x points, and then you have y points, and that's exactly what they are. So I'm going to go back to purple. And we need to break that down now. So we have y2, so that would be 3 minus a negative 1. All right? And that's all over 3 minus a negative 3. Okay? So if we look at that, m's going to equal, you're going to put that in your calculator. What is 3 minus a negative 1? So if you're putting that in your calculator, I'll give you a second. What are you going to end up getting? What is 3 minus a negative 1? Well, if you're putting that in your calculator, and I'm going to do it for you as well, 3 minus a negative 1, you should get a positive 4. And that makes perfect sense, because we would be thinking keep, change, which would change both of these signs to a positive. That's going to be the same case for 3 minus a negative 3. That's going to make them both positive, which would make it a 6, because 3 plus 3 is 6. Now, we notice on this one, we can reduce 4, 6. So 4, 6 is going to reduce to, we can divide each, the numerator and the denominator by 2, and that should give us, in the end, 2/3 for our slope, right? And this is a positive line, right? So it's a positive slope, and that's what gets us our 2/3. Okay, so to end it up over here, I'll circle this one in red. Down here, we can do the practice. So you can see if you can do one just using the actual line. Can you figure out what the slope is from the line for number 3? And then I'll give you the points for number 4 to see if you can use the slope formula and practice this and get the correct slope from that. So our points here are going to be 1, 2, 3, 4, negative 4. And that is 0. And this line would be 0, negative 1, right? So we'll label our x and y axis so you can see it. You get your x and y axis. So this is a quick review into slope, finding slope from a graph, but also applying and using the slope formula to find slope when you are just given 2 points. Now, this is very important because you may not get a graph like we have here where you can, do rise over run and count the boxes or the squares on the grid. So you're going to want to use a slope formula, especially when you only have 2 points going through. And then obviously when you get a graph, you can do rise over run and count the squares of the grid. So please let me know if you have any questions or concerns. You can email me. I'll see you guys all in class very soon. Bye.